Hello there! This video is on two different topics for linear functions. The first one is learning target 1, which says that I can identify a linear function from a graph, table, or equation. Okay, so you have some things to fill in on your sheet. You can see like the center of our sheet here says linear function, and then we're going to look at a few different things regarding that. So a definition that might be helpful is that a function is linear if the rate of change is constant between any two sets of points. So make sure you're filling that in on your note sheet. A characteristic that is helpful to remember is that the graph is always a straight line, so you won't see any points or curves on it. And then I provided a few examples and non-examples. I think the graphs are easier to look at first, so you can see the graphs under the examples are all straight lines. So this would be a line of a graph with positive slope. This would be a linear function with negative slope. And then these are special cases, so this is a slope of 0, and this is the undefined slope. So those are 4 examples of linear functions. And then when we look at the table, we want to make sure we calculate our rate of change. So what I want to do is look at as x increases, is y increasing by a constant amount. So for example here, 0 to 3 I have to add 3, and then 2 to 9 I add 7. So I want to see if that stays constant for my next set of points. So 3 to 6 I would add 3, and 9 to 16 I would add 7. So it stayed the same when x increased by 3, y increased by 7. So that is linear. For non-examples, you can see this first graph comes to a point. It's actually an absolute value function. And this second one has a curve. That's a parabola, and that's a quadratic function. So those are not linear functions. They are not examples. As for the table, let's check out what's happening there. So my y from 1 to 7, that means I increase 6. Negative 5 to negative 4, I increase 1. So I'm going to check the next point and see if it's consistent. 7 to 11 is adding 4. Negative 4 to negative 3 is adding 1. So these two are not the same. The x's are increasing by the same, which is good, but the y's did not, so that is not a linear function. Okay, we have a couple examples here. Let's start with the graphs first. So if I look at the bottom graph here, kind of follow it along, I see it straight at first, but then it hits this point right there where there's a point and it changes direction. That would be non-linear. It's not just a straight line, it changes direction. Let's look at this other example here on the right side. That's definitely a straight line, no curves, no points to it. That would be linear. Alright, let's look at that first table. So I'm looking at the table on the left. Remember, we are looking for a constant rate of change. So I'm going to check what my x's and y are going up by. So 10 to 4 is subtracting 6. Negative 2 to 0 is adding 2. So now I need to check if my other sets of points show the same thing. So 4 to negative 2 is subtracting 6. 0 to 2 is adding 2. So far, so good. Negative 2 to negative 8. Minus 6, 2 to 4 is plus 2. It stays consistent. So this one would in fact be linear. Let's check the one on the right. 0 to 1 is adding 1. Negative 1 to 0, also adding 1. 1 to 4 is adding 3. 0 to 1 is adding 1. So here I can see my x is both increased by 1, but my y is increased by a different amount. This would be non-linear. Sorry, that got a little squished in there. I don't need to check my last point because I've already proved that it's non-linear. And then we have 2 equations which we haven't looked at. When it is a linear equation, you're looking for just a plain x in the equation. So it's x to the power of 1, we just don't show the 1. So anything that would not be just multiplying by x in the equation is going to be non-linear. So this first one here, y equals negative 2x plus 4, there's our x right there being multiplied by the slope. That one would be linear. I'm going to do an L. For the second one here, I have an x squared. So the x1, it's no longer a 1. It's not a regular x. It's got an x squared in it. So that would be nonlinear. Alright, and the second part of this video is about slope. So I can find slope from a graph, table, equation, and 2 points. If we think back to slope, slope is the steepness of a line. It's also referred to as the rate of change. So you guys maybe also saw this as like rise over run, or change in y over change in x, or y2 minus y1 is over x2 minus x1. And we always use the letter m for slope. Okay, we're going to do a couple examples. Let's start with the graph. I need to pick 2 points. So maybe the points I pick are here and here. And then for a graph, I want to do rise over run. So what that means is I have to count how much I go up or down first, and then I have to see how much I have to run right. So finding slope from a graph is like reading a book. So I start at the left side. So I'm going to start at this point here. I'm going to count up. So I have to go up 1, 2, 3, 4. So I went up 4. I have to count how many I have to run right. It would be 1, 2. So 4 divided by 2, I can simplify to 2, and that would be my slope here. Let's look at the table next. I'm going to do change in y over change in x. So change in y from 5 to 8 would be plus 3. Change in x is plus 1. Let's do a couple more and make sure we have this correct. 8 to 11 is plus 3. 0 to 1 is plus 1. 11 to 14 plus 3. 1 to 2 plus 1. So it looks like my y's are changing by 3. So my slope is change in y over change in x. So 3 over 1, which I can simplify to just 3 if I want to. That would be my slope shown here. It's positive. That line's going up. And then from 2 points, we have a couple options. I know some of you guys last year liked the bar method, so you would connect the y's, connect the x's. So I would treat this as change in y over change in x. So to get from 1 to negative 1, I would have to subtract 2. To get from 3 to negative 1, I'd have to subtract 4. So my slope is showing up as negative 2 over negative 4, which I can simplify to 1/2. That's my slope there. Some of you guys like the formula better, so I would label this first ordered pair x1, y1, second one x2, y2, and then I can follow the formula y2 minus y1 over x2 minus x1. So my slope here would be y2 minus y1, so negative 2 minus 4, over x2 minus x1, so 2 minus 0. Negative 2 minus 4 is negative 6. 2 minus 0 is 2. So my slope is showing up as negative 6 over 2, which I can simplify to negative 3. A couple more examples. For the table, let's remember we have to do change in y over change in x. Let's look at our change in y's. 2 to negative 2 is subtracting 4. And the fact that it's subtracting is important. 1 to 3 is plus 2. Negative 2 to negative 6 is minus 4. 3 to 5 plus 2. Keep checking this for consistency. So it looks like my slope is negative 4/2. So I can simplify that to negative 2. Now right here I need to pick some points again. That point falls nicely there, and so does this point. So I'm going to think about, I'm doing rise over run. And rise actually means that I go up or down first. So in this case my line's going down. So I have to go down 1, and I have to run right 2. So my slope is negative 1/2. Thanks for watching.